Here is a 1987 Yamaha model KX-200 cassette deck. This has got some pretty severe problems, the least of which is the eject mechanism is messed up. It's not the door that's jamming, it's actually the mechanism that does not fully release the door. With the cassette inside, we find out there is no fast forward, no rewind, and no playback. And before you say, oh, that's simple, it's just a bad belt, the belt in this appears to be fine. Here is the inside of the cassette deck. The top cover screws are missing, so it's easy to open up. The mains power cable has been replaced improperly. There is no strain relief in the back. I can just stick my finger through the hole right here. Here is the mechanism. It's a 2-motor mechanism. Relatively simple, I would say. This is a sort of a middle-of-the-line cassette deck. The first problem is the eject. Now, if I push eject, it moves a little bit, but not much. And see, this whole entire top part, this is supposed to go all the way down like that, but it doesn't. So, likewise, the latch that latches the cassette door does not fully retract, so that's why the deck won't, the door won't open. Now, the nice thing is this cassette deck is simple enough so that it will let you activate all the functions even without a cassette inside. Taking a closer look, if we activate fast forward, this motor right here is running, but the associated reel doesn't run. And you can hear it does not release the brake, and that is most likely the problem. That is why fast forward and likewise rewind are not working, because connecting this motor to these reel hubs are only some gears. So there are no belts, there are no idler wheels, there is nothing that could go bad. So I'm pretty sure the fault is that it doesn't release the brakes. Likewise, the problem with playback is an unusual one. You can hear this motor is running to drive the take-up reel, but once again it doesn't release the brake, so this motor does not succeed. Now, while I do notice the counter belt is missing, which indicates that somebody has had this mechanism out before, from what I can see, the capstan belt is there, it's in place, it looks to be fine. The problem is that the motor doesn't turn. The motor seems to be dead. If I measure the voltage on the motor, you can see the motor does get power. For some reason it only gets 10 volts, that's a little bit low, but power is present, yet the motor does not turn. To continue the diagnosis, I'm going to take out the mechanism. There are 2 screws down there, 2 screws down there. These 2 screws hold the mechanism to the front, and the decorative cover on the cassette door needs to come off. With the mechanism turned on its side, we can see what is wrong with the eject mechanism. There is this main lever, and you can see there is this piece right there that's blocking this lever from moving down far enough to release the door. See, the door is still caught on this catch. Now, this piece seems to be there intentionally. So my guess is when the capstan drive failed, the cassette deck had just started to engage one of the functions. So it had not yet released the reel brakes, it had not yet move the head bridge or anything like that, but it had already moved this piece outwards to lock the door. So in fixing the problem with the capstan drive, we should also be able to solve this problem with the eject mechanism. In fact, we now have a pretty good vantage point. This is a counterclockwise motor, so if I try to get in here with a screwdriver, you can see there is the belt. The belt might be a little bit loose, but it's still there. Still looks fine. If I try to move this counterclockwise... Oh. Okay, well, I was expecting by sort of rubbing the screwdriver across the belt I'd be able to turn this, but this motor appears to be seized. The electronics are still working and they are loading down the power supply, and that's why we're measuring only 10 volts at the motor. Okay, so I'd say this motor needs to come out. Let's start disassembling the mechanism. Now, first of all, there is a spring down here. I have no idea what it does because it doesn't seem to pull anything together. But I'm going to unhook it. There it is, as you can see. Next, I'm going to mark this cable to make sure I remember it's the first position in this connector. This goes down into a switch right there. It is a switch, so maybe the polarity of this doesn't matter, but who knows. Better to be safe. Now, you push down on this connector to release it. That's these two cables out, and those are the only cables I'm going to remove. I think I can get away with leaving all the other cables in place. So this screw only holds the circuit board in place, so we don't need to worry about that. But this screw, next screw is in that corner. Take that out, and then we have a third screw that you can just make out through a hole in this circuit board. This is going to be interesting to get back into place once the repairs are done. Might be doable with a magnetic screwdriver. And now this, the back plate is now loose and we can lift it off. And of course making sure that we don't break anything. See, it's now getting caught on the cables, but as I said, I think we don't need to remove any more of those. It's only a matter of untangling them, giving them some slack. Okay, that's looking good. And there we have the other side. Let's get rid of this belt, or actually this belt is in really good condition, so that's going back in. Now the motor, it will turn kind of, but it's definitely not spinning freely. Now the motor turns counterclockwise, so from this vantage point we have to turn this clockwise. And yeah, see, this cam gear is engaged. And okay, was that it? Seems like we're back in stop mode. So let's see. Let's move this back down and move this around. No, the catch. No. Look. The catch is right there, but it has retracted. So eject works again. So that is the first problem solved. I tried lubricating the original motor with a silicone oil, but if anything, that has made it even worse. This is almost impossible to turn now. And then I got lucky. I took out the motor, and just to confirm one last time that it was bad, I turned the pulley manually, and I turned it quite forcefully, and that was when the silicone oil finally made it down into the bearing, and look at that. That is running nice and freely now. I fixed it. I can apply power, and as you can see and hear, it's running, and it's running silently. So I can put this motor back in. I cleaned the pulley and the flywheel with isopropyl alcohol. I applied some fresh white lithium grease to the back bearing of the capstan because the original stuff was kind of sticky. And I cleaned the belt with window cleaner. This is in really good shape, so this is going back in. And to do this, I'm going to hook the belt over this metal piece that's standing up over there to hold it in place while I reassemble everything. Hold the belt to the flywheel and, let's see, try to bring it across without touching it to the center because that has grease on it. Like so. Almost. Okay, now you got to look around in these mechanisms because that is how the manufacturers of these things are doing it while assembly themselves. They have a place to store the belt while the back piece with the motor on it goes in place. Now I'm going to move this down into place, and I have to say this would be easier to do without a camera in the way. Well, yeah, something does not quite want to align on this side. Yeah, I'll have to turn off the camera for this, I'm sorry. Everything went to plan. I was able to very easily transfer the belt from the metal post on the chassis to the motor pulley. I now have the mechanism loosely put back in place. Power is reapplied. Let's see if the mechanism now behaves a bit better. Oh, that's looking good. We got fast forward. And we have rewind. And it looks like we have playback. Yep, I can see some signal registering on the VU meter. I now have the cassette deck connected to an amplifier, and as you can hear, it does work. It does play, but there is a problem, and you can hear it if I insert a blank cassette. Hear that? Really annoying ticking noise. Well, this had me puzzled for a little while, but I finally figured it out, and it's very easy to repair. Yeah, the ticking is because the mechanism was not grounded properly. I took the mechanism back out because I still need to replace the counterbelt, and for that I'm going to take out this decorative back piece. It's also a good opportunity to clean that. This, in theory, is a nice mechanism. You can see we have gears where older mechanisms had various idler wheels. Of course, the idler wheels over the years go bad, and then you lose torque on the take-up and supply reels. This mechanism has gears. Those don't go bad, or do they? Unfortunately, I'm now finding confirmed what I had been thinking all this time. This is the same mechanism as you find in a Denon DRM-07, as well as another Technics cassette deck. I don't remember the model number of that. The Denon DRM-07 was my very first cassette deck. I got that from my parents. And the problem with that, you can see there is the gears right here in between. There is this gear on the rear drive motor. This is a relatively thick gear, but down below is a very thin gear, and that is what transfers motion from the motor over to the take-up and supply reel. And this very thin gear goes bad. It's the same thing as happens with many Philips cassette decks. This material, it's kind of a soft plastic to reduce noise. And this goes even softer, and then the teeth start breaking off. And that happened on the Denon DRM-07 over time. At first, you had a clicking noise because only one tooth was broken and it would skip over that. But eventually more and more of these teeth broke off, and then finally there was no more drive to the take-up and supply reels. The same problem also on this Technics cassette deck. On that, when I got it, this gear was already broken, so the deck was unrepairable. Yes, unrepairable. Unfortunately, I have to say this because there is always this crowd of people that says, "Oh, it's no problem at all. You can just 3D print a replacement. It's magic." Yeah, it's not magic. It's impossible. See, if I try to zoom in a little bit, the camera makes this look relatively big. But this, I mean, take the screwdriver for comparison. This is a tiny little screwdriver. This gear, you can see a tooth right there. This is even smaller. 3D printers have a limited resolution. You can't print something like this. You can't. No, it's impossible. So please don't tell me to 3D print a replacement. So anyway, to cut a long story short, unfortunately, this Yamaha cassette deck probably won't last forever. Reassembly is the reverse of disassembly, and there is the new counterbelt. And here is the new power cord, complete with the proper strain relief. And testing the playback speed, it's fine. It's very close, as you can see, so I'm not going to mess with it. One interesting thing I noticed, this right here looks like a bit of a problem. The two channels don't play back at the same level, but this must be a deficiency of the circuitry, because if I go and unplug the scope and plug in the other channel of the amplifier, that fixes it. And there it is, the 1987 Yamaha model KX-200 cassette deck, all cleaned up, including the heads. I found some new screws for the top cover. It has all been put back together, and I just made this test recording. Thank you for watching.